Alright, so I think I'm recording here. Let's take a look at this problem. We have a rational function, a ratio of polynomial functions. They're asking us for three things: the domain, and to identify any vertical asymptotes or holes that the graph of this rational function has. So we want to focus our attention on the denominator, and we need to solve this quadratic equation. We can solve it by completing the square of the quadratic formula, but we'll need to write it in factored form to also factor the numerator to see if this fraction reduces at all. So let's use our x method. If we multiply the first term times the last term, we get the top of our x. If we use the middle term for the middle, two values that multiply together to give you 36 but add together to give you 13 are 9x and 4x. And in a table, you write the first term and the last term, which is 6x squared and 6 along one diagonal, and then the two pieces of information that you found in the x through trial and error in the other diagonal. We now factor both horizontally and vertically along these lines. What's common to 9 and 6 here is a 3. Both of these are even numbers, and it does check out that 3 times 2 is 6. We look here, and both of these are even values, and they both have an x. And vertically here, 3 divides both of the coefficients, and then they both share an x in common. And 2x times 3x is 6x squared, and 2x times 4 is 4x, and 3 times 3x is 9x. And we already checked that 3 times 2 is 6. So that means that my denominator here factors to 2x plus 3 and 3x plus 2. Let's come in and do the same thing with our numerator. Let's factor it. We have no greatest common factor among the trinomials here. In our x, our middle term is 12x. Our first term times our last term is again 36x squared, and 6x and 6x. That wasn't the same problem as last time, was it? No. Alright, so we make a table. In my table, my first diagonal is the first term, and I'm doing the numerator, the first term and the last term of this trinomial from standard form. Along my other diagonal is the information I found in the trial and error of my x method. I factor these guys. They're both divisible by 2. These are both divisible by 2. This is, yeah, I thought it looked like a perfect square. 3x divides, so 3x times 3x is 9x squared. 3x times 2 is 6x. So this guy is factoring to 3x plus 2 times another 3x plus 2. Now I don't want to reduce this yet because I haven't found my domain. It will never reduce if x is negative 2/3. So if I set this equal to 0 and I set this equal to 0, it's a two-step equation. If you subtract 3 and then divide by 2, and if you subtract 2 and then divide by 3, well, negative 3/2 is smaller than negative 2/3 on a number line. So from negative infinity up to negative 3/2 union negative 3/2 comma negative 2/3 union negative 2/3 to infinity. So now I found my domain. So now I can go up to my expression and reduce this fraction. I can cancel these common factors. 3x plus 2 divided by 3x plus 2 is just 1. And when you have 3x plus 2 times 1 and 2x plus 3 times 1, it's easy to multiply by 1. So our negative 3/2 is that's the factor that remained. That's our vertical asymptote. So our vertical asymptote is the line x equals negative 3/2. The first value that we excluded, because that's the value that if you plug it in here, it causes division by 0. The hole in the graph, the x-coordinate of the hole was the other value, the negative 2/3. Now we need to plug that negative 2/3 into the reduced fraction. Let's do that down here. If we take 3 times this negative 2/3, that's a negative 2 plus 2, and that gives me 0. Well, the negative 2/3 here is not, we know it's not going to be 0 because, it was this factor that caused it to be 0. So we can double check that. That's not 0. Since my numerator is 0, this fraction reduces to 0. And this hole in the graph is appearing on the x-axis. Alright, so there's our answer. We can verify this on the online graphing calculator. Alright, so I've got for problem 9. Alright, so it won't illustrate the whole unless we look at the table, but it should, let's zoom in a little bit. Zoom out, I mean. It should illustrate this vertical asymptote. It's easier to see if we graph the line. So negative 3/2. So at x equals negative 3/2, and if we make that a dashed line, because technically it's not part of the graph, we're just doing this to visually make it easier to recognize that, the graph is getting closer and closer and closer to that without touching. So we were correct in our vertical asymptote, and if we look at a table, we can illustrate that there's a hole because it'll be undefined in our table. If we key in negative 2/3, it's undefined, and that's where there was a hole in the graph. So that point, negative 2/3, or excuse me, negative 2/3 is not related to any y value. Now the x equals negative 3/2 was a vertical asymptote. It will also be undefined in the table, although we see that from the graph, from the dashed line. We recognize that immediately. So I hope that helps.